Right, I've just stripped down the headstock on my Myford ML7. Originally I had these white metal bearings in the headstock and the unhardened spindle, and I've been getting a lot of problems with that, with vibration. I actually think the front bearing is distorted somewhat, so I'm changing over to a hardened spindle and phosphorus bronze bearings. So this is a used spindle and bearings, came off another lathe, and when I got it, I've tested the bearing on the spindle like that by hand, and when holding it together I found it turned very easily, so there was no actual grip on the spindle. So what I did was get a nice flat surface plate like that. This one's just like a kitchen hot plate made out of marble, and using a bit of 500 wet and dry, I'm just rubbing probably about a thou off of the surface of each side, and then I found when holding it together again and pushing it together, you can feel that it tightly grips the spindle. So I did that on both the front and the back bearing. Now it's very important, if you buy a used spindle like this and bearing, the bearings are matched to the actual spindle, and if you didn't see it come off of the previous lathe, you must work out how the two halves were matched. And this one I can see is the top one, because I can see some like cosmetic marks, surface marks on there, where the cap on the top there and the oiler hole goes through. And so that one's the top, and then I looked in the actual running part of the bearing, and there's a score mark at the front of that one there, and a score mark obviously in the other side, so I know they're matched together in that position. And the back one was easy to match up because of the wear marks on the back face. So if you have the chance to buy a spindle and bearing set, obviously make sure you get them together. If you bought a spindle on its own and tried to match some other bearings to it, I doubt very much whether you'll ever get it right. And also remember that the unhardened spindles that go with the white metal bearings, you can tell it's an unhardened one if you measure the bore at the back end, and you'll find it's about 15mm in diameter. And then the later version, the hardened spindle, you'll find that it's about 17mm in diameter, but everything else is exactly the same. Also, Myford still sell these new with a set of bearings, so it's good that they're still producing that one. It's a bit expensive, but like I say, they're still making it and selling it, so it's great that you can actually get the part. So just before reassembly, I'd just like to show you the back gear mechanism on the Myford, and it's all part of the pulley here. You've got the back gear that's fixed in the back of the pulley there, and this is the actual toothed part that you use when you operate the back gear lever. You undo this screw here, this Allen bolt, and slide it forward and lock it up again, and that disengages the teeth there from this gear here, so you're actually able to use the back gear and the slowest speeds on the lathe. So this is why you never use the back gear to try and get a stuck chuck off of the lathe. I've heard stories where people have broken this part, or this toothed part here, where they leave it engaged with the lathe stopped, and then they engage the back gear, which obviously locks the spindle, and then they try and get a stuck chuck off, and what that does, it either strips these teeth off here or breaks this little toothed part. Now you can get that toothed part from Myford, and you can obviously get this part, and it's very easy to get to if you ever need to change it. In fact, the whole headstock assembly here is very easy to strip down. You only need a couple of Allen keys and a nice soft plastic mallet, which you can actually knock all the parts off of the spindle with over a nice soft surface like this. So firstly, make sure the wood rough key is in the spindle there, and I just tip it back slightly, and then the back gear goes on and slides over the wood rough key. Like that. Then the pulley goes on, and the gear locates on that little toothed part that I've just shown, like that. Next, it's the steel spacer, slides on there like that, and when it comes down there, it becomes an interference fit. And I've got this nice piece of Tufnol here. You can use a bit of wood or plastic or whatever, and use that to knock that into position a bit more. Just a tiny bit of movement there, that's correct, and that one's okay. Next, it's the thrust bearing. Make sure it's nice and clean, obviously, and grease it up with a bit of molly slip or something. That one goes on there like that, and then the assembly is ready to go into the lathe. But just before I do that, I'll show you where the rest of the parts go. Obviously, when it's in the lathe, the bearing would be on there like that, and then there's a small hole at the back of the spindle, and there's a tiny little pin that goes in that hole. So when you're taking the spindle down from the lathe, be careful you don't lose that one. And then a collar goes over there. That one's got a slot in it which goes down over that pin. Then there's a screwed collar which goes on the back like that. Obviously the bearing's in between, and you adjust that one up to take up the free play and adjust the end flow on the spindle. And when you've done that, you just lock that Allen screw down lightly to stop it coming undone. Next, it's the small spindle gear goes on the back, and that's a nice tight interference fit. Obviously you have to use a plastic mallet to knock that one on, and I've actually tried it and tested it in the lathe, and with just the interference fit it runs the gears nicely and the feed and doesn't seem to slip. And I say that because on the old spindle, when this gear was on the back of the spindle there, It was obviously drilled and tapped for 2BA, and a grub screw screwed in the back there to prevent that from spinning. And the new spindle, this spindle here, doesn't have any drilled marks on it, so I just presumed they knocked that one on with the interference fit and use it like that. I will try and find out. If anyone knows, I'd like to know how they actually lock that one on, or whether they just, like I say, tap it on there and use it as it is. I'd be very interested to know that. So I've put the back bearing lower half in the lathe there. Make sure it's thoroughly clean, and then make sure you get the bearing half the correct way round and just push it down over the pin like that, and that's in its correct position. And I'd just like to say here that when you're actually stripping this headstock down, to get these bearing halves out, never use like a metal hammer on them. All you need to do is use a small plastic mallet like this, and just keep gently tapping the side there, and they will come out very easily without causing any damage to them. So that's worth remembering. Don't use any metal work to disassemble these. And it's obviously exactly the same method to get the top one out, of the top half. So these lathes have shim on this face here to adjust the tension on the bearings, and you can actually buy a laminated block shim from Myford, which is pressed together, and you can peel like 2,000 parts off of it at a time until you get the correct amount between the bearing and the correct tension on the bearing. But I just use brass and steel shim that I've made. And you can either make them like that, they're quite difficult to make, use a punch or something to punch the hole out. But I found that you can just cut squares and put them either side of the hole. So to get those right, or to get the right amount, you have to put the spindle in, put the top cap on and tighten it down. If it locks the spindle, you obviously put a bit more shim in and work out which one is locking the spindle. If you lock the screws on the back and it locks up, it's obviously the back one. And you build the shims up until you get free movement on the spindle with the Allen bolt screwed down tightly. When you've got the chuck on there, or you can put a bar in the spindle and a clock on the top of the spindle and give the spindle a lift, and you can see how much movement there is on the clock. And I when I got this one right, I noticed I had 1,000 movement and maybe up to 2,000, and it was running nice and free still. And I checked the spindle run out, and it was running dead true. Also, when you're putting these shims in and adjusting and checking, be very careful that you have them back far enough that they don't overhang on the edge there. Otherwise, when you put the cap part on the top, it gets caught in between and gives you a false reading. So on reassembly, I get a small pipette like that with some molly slip and give it a good dose in the bearing there, both bearings, and I put some in the back gear at the bottom there. and that coats the bearing with molybdenum disulfide and graphite, and prevents it from seizing up. Then the spindle assembly goes in there like that. You can see what a beautifully machined piece of kit it is. Next, I turn the spindle so that the little hole there is in the upright position, and put the pin in that one before I put the cap on the back, and just recheck the shims are not overhanging like I said earlier. And then I fitted the other bearing half into the top cap, and when I'm putting that on, I'm being very careful that I don't move those shims out of position. So you drop it on, and if it goes on nicely like that, you know that it's not, the shims are not overhanging into the gap like I said. And then put the screws in and just lightly tighten those down for now. Like that. And the same with the front bearing. And tighten those up nice and tight. And the spindle still turns nicely. And there's no run out at all on that one. And when you lift it, I'm putting very good force on that lift, but there's no real movement there at all. When I've got the chuck on and did that, that would probably be about a thou. So that is fully adjusted on these bearings, and the shims correct. Next, I take the gear lever off the back there, and the collar with the slot goes over the small pin. Next, it's the screwed collar goes on the back to adjust the end flow. So I just screw that one up finger tight, and then just back it off very slightly, and then lock that grub screw onto the back there to stop that coming off. You just do this one up very lightly because it's going down onto the thread, so you don't want to damage the thread. Like that. And that one's done. And then I put the gear on the back, and tap that one on. There with a plastic mallet. So that's the lathe assembled, and before I start it up I fill my front oil cups with molly slip, make sure the oilers are on and that it's in its slowest speed, and then there we go, and you can see there's hardly any movement at all on that clock. Probably just a quarter of a thou, if that. And then obviously just check when it's been running for a while to see how warm the bearings are getting. I found after I put this new one in that my chuck and collet runs out quite a bit, so I'm going to have to re-skim the back plates. So that's about it. When I've re-skimmed my back plates and put my chuck back on, I shall do a test on turning and see how it goes. Also, if you're doing this job, check out the comments section under the video. I often put information there that I've maybe missed out in the video, and other people write very good information there as well.